Hi everyone, I'm Phil McCaffrey from 3R Prep, and this is our live stream show we call 8:30 Prep. And today we're going to practice doing it. It's not really a product that I'm selling yet, but it's a product that I hope to sell with my producer Damien. Say hello, Damien.
Hey.
So Damien from Olsch is over there. We're going to play this hopefully to the Olsch folks. Maybe somebody from Olsch is watching again, so when I meet with them on Thursday. So today's lesson is M205, exponents and roots. And I said I'd throw in a little bit of logarithms. I went back over the lesson and I think I posted too much stuff. So I think what we posted is 2 weeks worth. So I think I've got next week's covered. So let's talk about an exponent. If we take a look at the board, an algebraic exponent has a base. Well, I have an eraser on. How about I get a pen on? Has a base and an exponent. So x is called the base. A, the exponent, is simply called that, the exponent. Any exponent, any number has an exponent, and that's the exponent of the power of 1. X to the 1 is simply equal to x, so 2 to the 1 is 2, 3 to the 1 is 3. We don't write the exponent 1 ever. It is just assumed to be there. One of the exponents that you do need to know is raised to the power of 0. Any number raised to the power of 0 is defined by mathematicians as equal to 1. It's important to note that 0 to the 0 to the 0 power is debated among mathematicians. I'm having a tough time with my words tonight. Is debated among mathematicians. But what would be tested is 2 to the 0, which equals 1, 3 to the 0, which also equals 1. What's the definition of an exponent? It is the number of times a number multiplies by itself. A number multiplied by itself. So if I have the variable a as my base in the exponent 4, it means a multiplied 4 times. The ones that you need to know that are words are squared and cubed. X squared is x times x. 2 squared is 2 times 2, which is 4. 3 squared is 3 times 3, which is 9. Why do we call it squared? Is that on my next one? Yeah. Here we have there's the question. Why do we call it squared? Why do we call it squared? Because it's the area of a square. Side times side. The area is side squared. You never say side to the second power. You always say side squared. Know your perfect squares for the ACT and the SAT. Know that they go like this. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. Very important one. 10 comes up quite often. 11 squared is 121, 12 squared is 144. 13, 14, and 15 show up just enough that you should know 169, 196, and 225. I would memorize this if I wanted a really high score. I would also know the first 3 cubes. Cubes come up quite a bit. 2 cubed is 8. 3 cubed is 37. I was going to write 3 cubed. 3 cubed is 27. 4 cubed is 64. And 5 cubed is 125. Why do we call the third exponent cubed? Because just like the square, the volume of a cube is side times side times side, or length times width times height. We call the cube side cubed. Negative exponents, almost always on the test. An exponent when it's negative means the reciprocal, the multiplicative inverse. So x to the negative 2 is 1 over x squared. Any number to the negative 1 is simply its multiplicative inverse. 1/2 is the multiplicative inverse of 2. 3 to the negative 2 is 1 over 9. Fractions can also have a negative exponent. So 1/2 to the negative 2, the negative flips the number, So it would be 2 over 1 squared, which is equal to 4. I could also put the negative exponent in the bottom. So if I have 1 over 2 to the negative 2, let's split this into 1 over 1/2 squared, or 1 over 1/4. When we have a fraction in the denominator, we multiply by its reciprocal, and this is equal to 4. 3 over 2 to the negative 2, we flip it, we get 2/3 squared, or 4/9. So this is 4 over 9. Multiplying bases. When you multiply bases, the same base, you add the exponents. So x to the a times x to the b is x to the a plus b. 2 to the 3 times 2 to the 4 is 2 to the 3 plus 4, or 2 to the 7th. 3 squared times 3 cubed is 3 to the 5th. You add the exponents when the bases are the same and you're multiplying. The opposite of that is dividing. Oh, I've got another worksheet on this. The SAT particularly likes to take this backwards. So if they give you an exponent that is added, x to the a raised to the quantity a plus b, it is x to the a times x to the b. So let's take a look at 2 raised to the 2 plus 3. I'm going to split that into 2 squared times 2 cubed, or 4 times 8, which is 32. That's the same as 2 to the 5th. Let's practice one now. X raised to the power c plus 2. That's x to the c times x squared. They like 2, and it's very interesting, 2 to the k plus 1. Students ask me what to do to this all the time. Well, it's 2 to the k times 2, which would actually be written 2 times the quantity 2 to the k. Same thing with 3 raised to the 2 plus t. I get 9 times 3 to the t, and would probably put that in parentheses. Now division. When we divide numbers of the same base, we subtract the exponents. So x to the a divided by x to the b is x to the a minus b. So let's take a look at our other problem. 2 to the 5 divided by 2 cubed. We subtract 5 minus 2, we get 2, and that's 2 squared, which is 4. Z to the k divided by z to the j is z to the k minus j. Once again, 2 to the k minus 4 would be times 2 to the negative 4th. That's how we do division backwards. And so this would be 2 to the k over 2 times 2 times 2 times 2, which is 4 times 4, or 16. Know your powers of 2. 3 cubed is 27. 3 divided by 3 to the t. So this would be a fraction. That looks like 2 to the 7. That's 27 over 3 raised to the t. All right. Doing it backwards, we have a couple more to do here. K to the 8 minus w, that would be k to the 8 over top of k to the w. Be able to write them backwards and forwards and do your exponents. 2 to the 5, 2 raised to the power 5 minus 2 is 2 to the 5th divided by 2 squared, or 32 divided by 4, which is 8, or 2 cubed. 5 minus 2 is 3. Fractional exponents. Fractional exponents are our roots, and that's why I include roots as part of M205, exponents and roots. You can email me for a list of all of the math concepts that I have, or pretty soon you could buy my book on it, which I hope to produce this summer. All right, the most common fractional exponent is 1/2. That's a square root. W to the 1/2 is the square root of w. If you use the square root symbol and put no number in it, it is assumed to be the square root. K to the 2/3 is the third root of k squared. The square root of k cubed is the exact opposite. So I've got k cubed and its square root. Notice how I put these two as opposites of each other. So any variable raised to a fractional exponent, k to the 1 over x, I make it the x root of k. X to the a to the b root would simply be x to the a power over b. That's the fractional exponent. So no to go forwards and backwards both ways. Square roots can be combined. The square root of x times the square root of y is equal to the square root of the quantity x times y. The square root of 2 times the square root of 8 is equal to the square root of 2 times 8, which is 16, which is equal to 4. Put that one in your calculator and play with it. The ACT particularly likes this type of problem, not the SAT. The SAT used to. Even and odd roots. If there is an even number if there's an even number in the root, the answer is almost always going to be positive unless it's a variable. We're going to get into that. That's a tricky advanced lesson. The square root of 4 is 2. The cube root of 8 is also 2. But you can take the cube root of a negative number and it's not complex. The cube root of negative 8 is negative 2. Because negative 2 cubed is negative 2 times negative 2, which is positive 4, times negative 2, which is negative 8. Look at, once again, our fractional exponents, 8 to the 2/3. So I take the cube root of 8 and square the whole thing, or take the cube root of 8 squared. The cube root of 8 is 2, 2 squared is 4. The cube root of 64 is also 4. We could have figured that one out. Now I've flipped it and made it a negative. So since there's a negative exponent, I have to flip the number so that now this becomes 8 to the 2/3. And that's my same problem here as here. It's pretty ugly, but it's not too bad. And I don't know why I have this one in here. X to the a raised to the t power. This should be a different concept. When I raise a power to a power, I multiply the exponents. All right, distributing an exponent. The quantity x times y raised to the a power can also be written as x to the a times y to the a. Know how this goes back and forth. Most students miss this. If there is an exponent over a fraction, it can be in both of the fractions. So if I have 2/3 quantity squared, it's 2 squared over 3 squared, or 4 over 9, as we've seen before in an earlier problem. Canceling exponents, this is a big deal on the ACT. A cubed over a squared, they're the same base, so I'm dividing a cubed by a squared, which just gives me a. B over b squared will just give me b. They cancel out by subtracting. Here's one of my favorite fun questions. If x squared is equal to y cubed, what are some possible values of x and y? This is where you need to learn to play the game of plugging in some numbers. What can I plug in? Well, if I put in 2 cubed and I squared it, that would be equal to 2 squared cubed, because when I raise a power to a power, I multiply. So this would be 2 to the 6th is equal to 2 to the 6th. So what is x? X is 8 and y is 4. 8 squared equals 4 cubed. That's kind of a fun one. All right, we have a couple of minutes left. That was 15 minutes, not too bad for a live lesson. I said the bonus was going to be logarithms, and I'm going to show log base 2 of 8 is equal to 3. because 2 cubed is equal to 8. The answer of a logarithm question is the exponent of the base. This is called the base. This is called the base. And that's lesson M205 with a little bonus 206. On the description, pull this out of my monitor, there are some worksheets, and I think that's what we'll do next week. There is an ACT worksheet and an SAT worksheet, and we'll work on those problems next week. Thanks for watching.